All right, let's jump right into this explainer. If you work with data, you already know the absolute headache of trying to make sense of human language at scale. I mean, it's messy. But today, we're demystifying exactly how natural language processing, or NLP, transforms mountains of unstructured text into a highly organized toolkit of actionable data.
Here's our agenda for today. First, mapping structure. Second, decoding meaning. Third, human-like interaction. And finally, the future of text data.
Section 1. Mapping structure, making sense of the mess.
Have you ever actually stopped to wonder how a machine knows which word modifies another? We humans do it intuitively, right? But computers, they need a very explicit map. It's almost like they have to draw this complex, rigid family tree just to understand a single sentence.
Well, that brings us to dependency parsing. Think of this as the foundational scaffolding of NLP. It dissects the syntactic structure by mapping out relationships, assigning highly specific labels like nominal subject or direct object. It literally connects the core head words to the words that strictly depend on them.
Now here's where it gets kind of cool, because this process actually changes depending on the language. For straightforward grammar, we use projective parsing, where dependencies are drawn neatly in a 2D plane without any crossing lines. But for languages with freer word order, we need non-projective parsing. Here, the grammatical dependency lines literally cross over one another to capture those complex, tangled relationships.
Okay, so the machine has successfully mapped the grammar. But how does it know who or what the sentence is actually about? How does it act like a superpowered highlighter to pick out the vital details?
Enter Named Entity Recognition, or NER. This is the vital tool that spots specific entities hidden within massive blocks of text. It knows the difference between Apple the company and Apple the fruit, and it categorizes them accurately into predefined buckets like people, organizations, locations, or even monetary values.
NER operates in a strict two-stage dance. First, it identifies a potential entity by looking at the surrounding context of the sentence. Then, it classifies that entity using multidimensional word vectors, essentially mapping out the mathematical meaning of the word to slot it right into the correct category.
Put simply, NER is the absolute cornerstone here. It's the silent engine that takes a chaotic, rambling paragraph and turns it into neat, structured data that's ready for serious business intelligence, information retrieval, or critical healthcare data analysis.
Section 2. Decoding meaning, reading between the lines.
So, it knows the syntax and the key players. But how on earth does a machine measure attitude? How does it detect the hidden sarcasm or the raw emotion lurking behind a customer's words in a product review?
That is where sentiment analysis comes in. It's a fascinating tool that assigns mathematical polarity scores to text. It essentially acts as an emotional decoder, figuring out if the underlying attitude of the writer is positive, negative, or perfectly neutral. It takes us way beyond just recognizing words into actually comprehending emotional expression.
And this emotional decoding happens at 3 distinct levels. You can analyze the overall sentiment of an entire document, break it down line by line at the sentence level, or even zoom in on aspect-level sentiments. That's where you see exactly how a customer feels about a specific feature, like, say, loving a phone's camera, but absolutely hating its battery life.
Beyond just the emotion, we need to organize this data. That's text classification. It neatly sorts documents into binary buckets like spam or not spam, multi-class buckets to sort news into sports or politics, or even multi-label buckets where an article can simultaneously be tagged as technology and business, which, as you can imagine, requires a much deeper level of context from the model.
It's pretty amazing to see how the underlying architecture for all this has evolved. We started with rigid, manually crafted rule-based systems using simple keywords. Then we moved to machine learning algorithms trained on massive datasets. And today, we rely on advanced deep learning models like BERT, transformers capable of capturing incredibly complex, long-range context.
Section 3. Human-like interaction, summarizing and talking back.
When we are absolutely drowning in data, text summarization is our life raft. Its entire objective is to condense sprawling legal cases or dense academic research into their absolute essential points. It's a total game changer for information overload.
But the models accomplish this in 2 distinctly different ways. Extractive summarization just acts like a smart highlighter,
lifting existing key phrases directly from the text. Abstractive summarization, though, that's much more advanced. It actually comprehends the text and rewrites the content using entirely new phrasing, exactly like a human assistant would.
Hey, what if you don't just want a broad summary? What if you want to ask the text a highly specific, complex question and get a direct, accurate answer right back? Question answering, or QA systems, handle this using two main strategies. A closed-book approach relies strictly on the internalized knowledge baked into the model during training. Think of an offline chatbot. Alternatively, an open-book approach actively and dynamically searches external databases or the live internet to formulate its answer. Whether they are handling simple factoids, complex definitions, or conversational queries, these QA models are the hidden engines behind the automated customer support systems, modern search engines, and healthcare assistance tools we rely on every single day.
Finally, Section 4, the future of text data.
So where is this rapidly advancing toolkit heading? The future is pointing towards some absolutely profound deep learning advancements. We're looking at cross-lingual systems that effortlessly jump between languages without needing specific training. We'll see multimodal models that seamlessly analyze text right alongside audio and video, and a much sharper ability to detect true human emotion and sarcasm.
Which leaves us with a really fascinating, almost philosophical question to ponder. As these systems master the subtle nuances of sarcasm, perfect cross-lingual translation, and synthesize abstract thought, are they still just processing our language? Or are they finally beginning to truly understand it? Something to think about until our next explainer.